Hello, ladies and gentlemen. Good morning. Let's start our Module 7 live lecture. Uh, Today we will cover Chapter 8 in the textbook about the confidence interval, or we call it interval estimation. Excuse me, a little bit under the weather. Okay, let me share my screen with you as we also start the recording. Okay, so you should be able to see my screen by now. So today, the topic is about the confidence interval. Okay, let me go over the the PowerPoint with you. Okay, you know, first of all, why do we need to do the confidence interval estimation? Because in hypothesis in a population, we want to know its population parameters, but when we don't know, have no idea about what the population parameters are, then we construct confidence intervals. Confidence intervals are constructed through the combination of the sample mean and the sample standard deviation to construct the confidence interval. And with that interval, we want to capture or include the population parameter. Okay. There are different type of the population parameters that we will cover down the road from today. There are population mean as parameter. There are population variance as parameter. There are population proportion as parameter. There are population two population mean differences as parameter. There are also the ratio of two population variances as parameter. So with these parameters, we should know what are their samples statistics to match them. When population parameter is a mean, population mean as parameter, we use sample mean to estimate it so sample mean is the point estimator. Here we see a point estimator, point estimate. Point estimate is a specific value of point estimator. So if population mean is a population mean is the population parameter, then we use sample statistic as estimator to estimate it. If population parameter is population proportion, we use sample proportion to estimate it. If population parameter is population variance, we use sample variance to estimate it. If the difference of the two population mean is a parameter, then we use the difference of two sample mean to estimate it. If the population parameter is the ratio of two population variances, then we use the ratio of two sample variances to estimate it. So each population parameter has its corresponding point estimator. Okay. Then use that with the and we combine the point estimator with its sample standard deviation. If population variance standard deviation is unknown, whether it's known or unknown, we will be able to construct confidence intervals to capture the population parameter. Okay, and the confidence level that go along with the confidence interval means the probability that this interval will include the target. When I say target, it's the population parameter. Okay. When I say a sample statistic, when I say bullet, that means as a sample statistic. Okay. So try to understand this analogy. In interval estimation, we the point estimator is like a rifle bullet, and but if you use a rifle sample statistic to estimate the population parameter, you always miss the target. Like you fire a rifle bullet a shot, then you always miss the target because it's a point estimator. So to increase the probability, which is to increase the confidence level, we use an interval instead of a point to include the target, to capture the target. So here in this case, we use our confidence interval to capture the target as parameter, population parameter. Okay, so the confidence interval is like firing a shotgun bullet. When you fire a shotgun bullet to hit the target, you hit the target with the range. That increase the probability of hitting the target. Okay, so this is the strategy that we use. Okay, this example shows us. It shows us what does the, for example, 95% confidence interval means. We know if we multiply, here there are 25 samples. So if out of 25, let's say 20, okay. 20 multiplied by 95% is 19. So that means out of 20 intervals that you draw from the sample, from the population, you can construct 20 confidence intervals. Out of those 20 intervals, there's one may miss the target, may not include the true mean, population mean, which is what we are after. So that's what it means by 95% confidence interval. Okay. Of course, it may, if you draw 100 samples and get 100 sample means and construct 100 confidence intervals, then there may be 5, perhaps 6 or 7 or 9 or more or less around that area. It may not be exactly 95, but in average, the larger the number of sample you draw, the more it will be average to be 95% of them that doesn't include the population mean. So this is the rationale. In practice, we don't draw that many sample. One sample is enough. But whether that sample will include a target will be dependent on the luck. Okay, you will just say that 95% that's reliable. Okay, so theoretically you can take unlimited samples, then then say 95% of them will hit the target or will include the target, or just take one sample and say this is 95% confidence interval. Then okay, so there are two situations when sigma is known. If you constructing a confidence interval and you know the sigma, then it will be using normal distribution. So here we can see how to use that to construct the confidence interval. Okay. So in order to construct 95% confidence interval, then you have two tail, each with 0.025 probability. And in terms of Z distribution, 0 is the center, and 2 is the number that will enclose 95% because according to the empirical rule, 95.45. Then we use the formula where Z equal to X bar minus mu over sigma over square root n. Excuse me. So you use that formula, you rewrite it, and you can include mu in the middle. Okay. We call this pivot method. Okay, pivot method. All right. In other words, Z. Okay, you say probability that Z be included in the 2 and -2 is less than or equal to 95%. Equal to 95%. Then you plug Z equal to X bar minus mu over sigma over square root n in there, and multiply sigma over square root n on all sides, then rearrange it, then eventually it becomes mu in the middle, and mu less than X bar plus 2 sigma over square root n, and mu less than mu greater than X bar minus 2 sigma over square root n on the as a lower bound. So you can derive that formula for the confidence interval for mu. All right. Okay, so this is a confidence interval. So in to solve any questions, to construct confidence interval for any questions, you just plug in X bar, plug in n, plug in sigma, and depending on the alpha, you divide alpha by 2, and then calculate Z. You will be able to construct an interval, like here. Okay. There are times when we, okay, 1 second. Then here, this part, this minus this Z alpha over 2 times sigma over square root n, this thing, this value is, we call it margin of error. Margin of error. Okay. And we denote it by n. So if you add plus or minus margin of error to X bar, then you will be able to construct the confidence interval like this. And we say this interval, 95% of time, it includes the population mean mu. So how, for fixed sample size, decreasing the confidence interval level, decrease the margin of error, and hence improve the accuracy of a confidence interval estimate. Okay. Decreasing the confidence level, when you decrease the confidence level, increasing the sample size, decrease the, well, Okay, let's look at this. Sample size and accuracy. Let's come back and look at this. Okay, how do we decrease the E? You know, margin of error. Error is not a good term, right? Error is not a good thing. We want to decrease the error. So as n increase, this may decrease because n is in the denominator. So the way to decrease this to increase the precision, accuracy, is to increase n. And in other words, to draw more samples to get a larger sample size. And if when need be, we want to limit our confidence interval to a certain, the margin of error to a certain upper bound. And based on this formula, and we say E is greater than or equal to this thing, then we reorganize this to isolate n on the left-hand side and move everything to the right-hand side. You will get this formula, which means the sample size you need to control the margin of error to an upper bound E, capital E. All right, so this is the formula. There are times when in elections, you want to control your margin of error to 1%, for example, or less, to make sure that you can guarantee the estimate for the prediction of any of the one who will win the election. So you increase the sample size. You set your E to a certain limit, okay, cap value. But that the price you have to pay is that n has to be has to match that value, which means it has to be increased. Okay, now let's come and see when the case when sigma is unknown. When sigma is unknown, we lost an important piece of information. Therefore, the two tails will increase. As you can see here, the green curve stands for normal distribution, but the blue and orange curve stand for T as T distribution. They are very similar, and actually when degree of freedom, which is sample size minus 1, equals to degree of freedom, when that degree of freedom increased to 30, excuse me, the T curve will overlap almost exactly with the standard normal curve. So with that, we can take advantage of this to accommodate, to address the variability introduced when sigma is unknown. So as you can see, the differences between the previous formula, when Z is here, you replace it by T and replace sigma by S. Everything else is the same. And this is a table showing you how to calculate the T. But I suggest that you use stat disk. Okay, there are advantages of using it, and I will show you in a little bit. Okay, instead of using Z, we use T. Instead of using sigma, we use S. So you get this new confidence interval. And this is to check the normality. So if all the points fall on the straight line, there is normality. Otherwise, normality assumptions is violated because the underlying assumption for T is that its population is normal. Otherwise, your sample size is large. Okay, here you see that a little bit violation of the normality. It may be removed to make it fit better the normal distribution. Okay, so basically, this is the content, the lecture part. Let me introduce you to the stat disk. Okay, type statdisk.org, and then you'll see this, and you download for Windows or Mac OS. Or you don't want to download, you can open an account, so use the cloud version. Okay, and that's easier. That's compatible to everything. Okay, so you have that, and after you download it, install it, you can go here and watch video. We have open playlist where you have videos for regarding how to use it. And there are many videos, including Excel, including status. So you can use either one. Okay, you can use either one. Let's see still. Okay, so here to use this one, you click on 7.2 to construct the confidence interval mu. Okay, so you will watch this video, all right, and let me show it to you. So here, with this example, you open it, click on data analysis. You'll see confidence intervals, and here are a list of the population parameters, which I call target. And you choose one. You choose one to be the target, to be in the hypothesis test. And here I choose mean one sample. That means mu is your population parameter. And then you confidence interval, confidence level, talking here, sample size, sample mean, sample standard deviation. If sigma is unknown, so if sigma is unknown, you plug in the population standard deviation. You plug in 10 here, and it will automatically calculate everything for you. You will have the margin of error, and you will have the 95% confidence interval. Okay, it's very easy. And how do they get this value? Use the formula I have shown here just now. Yeah, right here, this formula. Okay, manually, if you are to calculate, that's the that is the formula you use. Okay, let me see. All right. Okay. Now, let's come to the assignment. Okay, go to the first question. Okay, so with that, you can easily use the formula or stat disk, right? So if you do this, okay, move it here. All right, for analysis, confidence interval, and here we have, obviously, when X bar is given, you know you are estimating population mean, but you only have one sample because you only have one sample mean. So the target is mean one sample. Oh, sorry, mean one sample. Okay, so with that, you plug in 95, plug in N 100, mean 40, sigma. Actually, right here and click evaluate, you got the answer right away. And the confidence interval, also again, sample size n equal to 36. Population standard deviation, which is sigma, 9.6. And 96,000. Okay. And then you want 99.7% confidence interval. So you do everything just like you did just now. Change this to 0.997. This to 36. 9. Sample mean 9600. Let me see. Population standard deviation, confidence interval for new homes. Population 10. 36. Oh, it doesn't say sample mean. Let's read the question again. A government bureau published annual figures for new mobile homes. A simple random sample of 36 new mobile homes yield the following prices. The prices are here. Okay, so with this price, you will have to what? You will have to calculate. You open it here, open it in Excel, and calculate mean to be able to get the X bar to plug in the stat disk. Okay, use equal mean parentheses and select all the data. You will get the mean and to be plugged in to construct your confidence interval. And I will leave this to you. Okay, 99 confidence interval. Again, like this, you have to calculate the mean here, and the population standard deviation is given, and the sample size. So plug in everything there, you'll get confidence interval. What else is this calculating? Let's look at the example, and I don't have to calculate. Here, it used a formula, but I give you a shortcut by using stat disk. After you calculate the confidence interval, you what's the next question? Margin of error will also be given. Okay. What is confidence in pi longer? Y is the 90, Y is a 99% confidence interval longer than 95 because the reason is if you look at this here, you will see that this is 95, so Z is 2. But if you want the 99, then Z will be either bigger than 2, okay? Bigger than 2 or less than -2 to include the bigger area in the middle. So, and when you plug in an interval, it makes marginal error bigger. Okay, so it makes the interval larger. That is why. Intuitively, you can also make sense of it because in order to have a larger confidence interval, you have to have the larger interval width. Okay. All right. When standard deviation is unknown, population sigma is unknown, then you use T, and then replace by S. And the margin of standard deviation formula is, margin of error formula is here. But you replace this by Z by T and sigma by S. That's the answer. So, okay, so this is a concept type of question. Okay, when here is 1 minus alpha label, answer is already right here. Yeah. And the population mean mu is so regarding this is lower bound. Okay, so it should be at least. All right, and all right, so if alpha is 0.08, here is a way to calculate the alpha over 2. Okay, so alpha obviously is the sum of the two tails. So in order to calculate alpha over 2, divide alpha by 2 is 0.04. So you can use Excel, go to analysis probability distribution, normal distribution, and plug in what? Cumulative, in this case, 0.04 is to the area of, to the right, the area to the right of Z alpha over 2. So area to the left should be 0.96. 96. That will be your, give you the Z you need. Okay, and this is construct and locate the interpret 90% confidence interval. This is the same. You have n, you have mean. All right. Yeah. You will look at the two variables once each time. Construct the one interval for each one of them. Actually, it's right here. It's right here. So you just plug in the data. Not a big deal. Okay. With a large sample, confidence interval be valid if the population from which the sample is taken is not normally distributed. Okay, large sample, it should be okay because the underlying assumption is either that it has to be normal or larger sample size. Yeah. Because of central limit theorem. Okay. Okay, so this one is t-test. Okay, because sigma is unknown and sigma is known. The result that you will use, you get will be from the t distribution. Okay, so just plug in S in here, you will get the answer. Okay, all right. I think I pretty much cover all that you need to know for today. Please don't hesitate to let me know if you has any questions, and I'll be very happy to help you out. Sorry, I'm a little bit under the weather today, so you can hear me sneezing my nose frequently. Sorry about that. Okay, I think it's a good point to stop. All right, and feel free to ask me questions. So your job as part of the assignment is to make the most of the statistics. Of course, you can always use Excel, no problem. But in this sense, in this hypothesis testing and interval estimation and hypothesis testing, statistics is very handy and user friendly. Okay. All right. I will stop here, and I wish you a very good day. All right. See you next time.